because that one's really.
Then you can break it. You can. That's like worse than the openness itself. Like then you can steal a bunch of then you can read all of the. So because I'm a cryptographer, so okay, maybe I should start it with that. It's magical crypto powers.
And what's your talk on Crypto 101?
No, that was the one I did last year.
No, I watched this stuff.
Oh, okay. Yeah, but since then I've actually turned, that's one of my first slides, since then I turned Crypto 101 into a book. It's for free online. So if you like to talk, www.crypto101.io. And it goes into a lot more, because the biggest problem with the talk is, but it's so much stuff that, 45 minutes,
3 minutes.
2 minutes?
3.
3. Oh. I got time to edit my slides.
PyCons have you been to?
Only US or international ones too? So only US, like, I think this is number 5, and international, like, somebody asked me yesterday, and I started counting, it's like, 2 dozen.
That's cool.
Yeah, it's fun.
I really like it. It's my first one, but I think it's really cool to be here and just hang around, meet people.
Awesome. But aren't you, like, volunteering for the 5K and everything? Or?
Yeah.
So you're not involved with like Montreal PyCon?
Python.
That's what I thought. I thought you were a Montreal Python guy. Yeah, okay. Yeah, so like one of the guys yesterday, one of the volunteers, it was like his first PyCon, and he wasn't like involved in any like local user groups or anything. And the guy was like doing 50 different kinds of volunteering. This is, I mean, it's fantastic. I absolutely, I just. My first PyCon, I was scared.
I figured I'd try, like, I picked session chair, I picked session runner, I tried to volunteer everywhere. Just figure out, like, how it works and what I like to do.
Session chair and session runner is fine.
And I quit my job, like, maybe 6 weeks ago. So I'm not working.
I'm not sure if I'm supposed to say désolé or congratulations.
No, it's a good thing.
Or,
yeah,
okay, congratulations.
Yeah, it's really good. Actually, I'm going to start working in a week. But so I volunteered for like as much as I could. Keep busy.
Yeah. Well, it's essentially similar to what I'm doing with Crypto 101, the book. I don't know, you probably overheard because this goes over the staff room a lot, but I'm waiting to go to the US for my green card.
Your wife told me.
Yeah. So, I understand the sentiment, but I'm sort of reaching the point that for me it's been longer than 6 weeks. Like longer than 6 months.
Why is that not working?
Well, I mean, I'm doing like contracting here and there, but it's not permanent employment. That's not great. Once in a while, a steady paycheck is nice. But I am really glad because I completely understand what you're saying. Like, just the being able to volunteer stuff and
it's time.
Okay, cool.
Hi. Hello. This is LVH. His beard solves discrete logs in fields of small characteristics, and he'll be talking about mixing twisted with other code.
No, Firefox, do not show the menu bar. I'm LVH. That's my email address if you want to talk to me. Also at LVH on Twitter. And I'm here to talk to you about twisted mixing. So quick introduction. I would like to say that I'm a Rackspace employee, but unfortunately certain immigration processes take a very long time. They've had a chance to get rid of me several times, and they haven't. So I would just like to say that they're awesome people. So PyCon, this is one of the few other hats that I wear at PyCon, specifically right now, speaker hat. Normally, I'm a staff member. I'm currently doing financial aid and open spaces. The thing that I've been doing more recently, this started with a talk I did last year at PyCon called Crypto 101, which is, you can see it online if you're interested in introductions to cryptography. It starts with basically nothing and ends with a very high-level understanding of what does my browser actually do in order to get that nice green lock. I've also recently turned this into a book. You can get that on www.crypto101.io. But more importantly, I'm here today as a Twisted Core developer and, of course, a rampant Twisted apologist. This talk is about mixing code. It's about mixing Twisted with anything else. And that might sound like an extremely narrow niche, but this is one of the more common criticisms that I've heard of Twisted. And while I understand where that criticism comes from, I think that to some extent it is today at least a myth, and I hope to set the record straight, if you will. So I am not really going to talk too much about why you want to use Twisted, because quite frankly, I yap enough about that already. But just a very quick, there's a lot of stuff in Twisted that you might be interested in using. The really nice part about Twisted is there's just so many different protocol implementations, so many different features that all come together. And I think, therefore, Twisted mixing is a particularly interesting and topical subject for Twisted because it demonstrates how stuff comes together. And I hope through this talk you'll understand what I'm talking about. So prerequisites, just really Python. Some Twisted probably helps. Who was here for the previous talk? Stacy, who gave an introduction to Twisted? OK, so I'm going to go through the introducing Twisted part real quick, but I'm guessing most of you won't really need it. The only things that you really need to know about is a reactor. And a reactor is an object that reacts to events, really, seriously. That's it. And it then dispatches them. And what does a reactor interface, what does a reactor do? Well, for example, some reactor interfaces. I noticed while I was rehearsing this talk that I cannot say this without doing it to a particular cadence, and I hope that you recognize it. There's TCP and UDP and SSL and multicast, Unix, datagram, sockets, and some processes. Call in thread, call from thread, timed events, and FD sets. These are some of the interface of which code has come to Twisted. There may be many more, but they haven't been persisted. So basically, there's a lot of stuff in Twisted, and this is most of this is extremely low level. I mean, there are very few people who will ever actually have to deal with FD sets. But some of these, like, OK, TCP, SSL, there's a good chance that you're going to do some of that. So then a deferred, and this is a much higher level overview than from the talk before. So the only thing that you need to know about a deferred is it's an object you get now, and it will get you a result or a failure later. And most people are probably used to blocking APIs, where if you want to do something, and then so you do blocking read, and you get a result, and it looks to you like you're getting that right now, but obviously, for example, if you're downloading a web page, you're not getting it right now. You're going to get it a couple hundred milliseconds from now. And just in case some error happens, then you want to do something with that error. And if happy case, you get the result, then you want to do something with that result. And in a deferred that looks like this, you do the async read, and then you get the object that you get immediately for a result that you get later. That's the D. That's the deferred object. And then you add some callbacks, and the deferred will make sure that those callbacks get called. Again, this is very high. I'm really sorry if this is too fast for someone. I will not be offended if you get up because you don't really know Twisted or deferreds really well. I won't be offended if you get up right now, but this is as much time as I can spend on this. Now, some people really don't like this particular API. Therefore, there's something in Twisted called inline callbacks, and then you can write code generator style, which is, I guess, quite similar to async.io and the new Python 3, except that it's usually yield here instead of yield from. But you notice that besides the yield, this is exactly the same thing as the blocking API. But the async read is still returning a normal deferred. That is all the Twisted you need to know. So that's not a lot. Just going to talk briefly about Twisted in your app. It might be really easy to get started because people talk about how they don't want to add Twisted because they already have all this code and they want to add it. it might be possible to not have to care. What if you can just have this little separate component that you query over some standard API, and at that point, you don't really care what it's written in. It could be G-event twisted, it could be COBOL, it doesn't matter. And I realize that's a very, very lame kind of interop, because it's basically just dancing around the fact that you're not doing interop. But still, yeah, you can do it. Something that's probably much more common, WSGI, the Web Server Gateway Interface, which I think nobody has ever actually pronounced those words. So WSGI. How many of you have a WSGI app? I've had, at any point in time, had a WSGI application object. I mean, Graham, come on. Seriously? No, so one of... Anyway, so how many of you knew that Twisted not only has a very easy-to-use WSGI server, but actually has a production-quality WSGI server that you could absolutely use instead of Junicorn, for example? So, I mean, all you do is twistd, that's the command line daemon thing, twistd web -- WSGI equals, and then a fully qualified dotted path to an application object, and that will serve, that will totally serve your app. In fact, these slides right now are being served by twistd web. And you can combine those things with any regular twisted code very easily. And to demonstrate that, and this is where my talk is going to go horribly wrong, because it's Reveal.js, and this is just super dangerous, but I'm going to try it anyway. And of course, the sides are falling off. So this is an example of, this stuff is on GitHub, so you can play with it yourself if you like. This is an example of a Flask app serving a Pokey the Penguin-powered chat application. And most of the HTML that you're seeing is entirely Flask. This is regular, completely normal Flask. And the live chat thing that you're seeing, which is going to be bidirectional, you're going to see that in a sec that's bidirectional, that is being done by txsockjs, which is an awesome library that, so sockjs is basically WebSockets, damn it, even if the browser that you have to deal with is like IE6 or something else terrible, and it doesn't have Flash or whatever, then sockjs just goes like, yeah, whatever, WebSockets. So as you can see, it's much nicer if you play with it yourself. This is going to be on GitHub. You can see that there is twisted. No. Come on, out of hide. That Twisted is serving the WSGI app, and this is just a Flask, just a Flask app. And then you can combine regular Twisted with that knows nothing of WSGI, but is still running, for example, on the same port. This is not a problem. So the other thing that you might want to do is do some blocking code in Twisted. And this is probably one of the more common use cases. Now, the problem with Twisted is that you can't block the reactor thread. You can't block the reactor. Why? Well, because, Twisted is event-driven, and there's a single thread, and essentially the thread is waiting for stuff to, when the reactor is waiting for stuff to happen, some stuff happens, and the reactor passes it on to something else. But all of that is going on in the same thread. This is exactly the same story, like, for example, with Node.js. There's one thread, and it's doing things. The problem then, of course, is that if you block that thread by, I don't know, resizing some images in it, then nothing else happens. No I/O is going on. You can't serve new requests or anything like that because that thread is just busy. So a common example of this would be, like, for example, if you're using requests, which is an excellent library, but it's got a blocking API. If you do a request.get of a URL, that's going to block. And you can't do that in the reactor thread in Twisted because, well, you could, but then you have to accept the fact that nothing else is going to go on. It could also be some blocking computation. This is a horribly contrived example. I realize that, but I'm going to show you why this particular example is in just a couple of slides. So you can't block the reactor. So what else are we going to do? Well, either you don't block the reactor, or you block some other thread. So either you can't block here, so either don't block or block somewhere else. That seems kind of obvious, right? So how do you not block? Well, if you're I/O bound, this is the common case, then you can do asynchronous I/O. If you're CPU bound, then you can potentially cooperate with the event loop. For the async I/O example, it just so happens there's a library called Trek, which is essentially a Twistidified, what requests would look like if it had been written for Twisted. And in that case, you get a deferred instead of the blocking API, and all is well with the world. So that's the easy way of getting rid of this problem. You can also cooperate. I will say right now that this is kind of like very few people actually do this. But what you can do is, let's say that your loop can be broken up at some point. Instead of having your loop be running the entire time and blocking the reactor, you can, if your loop cooperates with the yield, and that's where the loop says, like, OK, I've done some work now, you can go do something. And then what will happen is the reactor will basically get a chance to do stuff, and then it will also, once in a while, give the generator, in this case, because it's going to be a generator because of the yield, it will give your blocking computation, no longer blocking, a chance to do something. And the two will sort of be intertwined up until the point where this for loop finishes and you're done. I absolutely, completely appreciate that this is a very small percentage of use cases, but that's why there's a more generic answer coming. Now, the problem is that not blocking is not always possible. I mean, it could be a blocking API like DB API 2, so that's the standard thing that you're probably using for talking to a database. Even if you're using like Django RM on top of it, you're probably using DB API underneath. WSGI, which is a blocking standard. It could be some opaque code that you can't or don't want to touch, like crypto code or Pillow if you're doing image manipulation. And you don't want to, and even if you wanted to, you couldn't just go ahead and go in there and rip it open. It could be at a kernel or a syscall level. I mean, file I/O. There's basically still no reasonable file I/O, no reasonable asynchronous file I/O. Certainly not a cross-platform one. On some platforms, you sort of can do it, but whatever. And sometimes it's all three of these. So it's quite possible that not blocking is just not an option for you, and you have to go block somewhere else. So again, the idea is you can't block the reactor thread, so we're going to go ahead and block a different one, right? So where do you do that? You can either do that in the same process. There's a helper function called defer to thread. It has a couple of friends like defer to thread pool. And what you're then just saying is like, OK, look, I give up trying to make this thing not block. And please go run it in a thread somewhere. And let me know when you're done. Right? And so out of that comes a deferred. And then there's no more impedance mismatch between your blocking code and your twisted code. You can do that in a child process. For example, spawn process is the default API for that, or the lowest level API for that. And that's a decent choice for all sorts of batch processes. Like if you just want to run some stuff in a directory, if you were doing that on a shell, like you would just do it, and there's no reason why you can't do the same thing in Twisted. So child processes, or even remote processes, so not directly a child of the one that you're dealing with, but for example, with a job queue, which a lot of applications end up needing anyway that have nothing to do with Twisted. So the very popular one here is defer to thread, because it's very easy to use, and it sort of mostly just appears to do what you want. So yeah, easy automatic deferreds. Yay! Downside is, of course, shared mutable state. There's a lot of shared mutable state that you previously didn't have to care about in Twisted, because there's only a single thread, so there's far fewer options for getting it wrong. It's very hard to write applications without shared mutable state, at least in Python, because, well, like the entire module system is one giant heap of shared mutable state. And one of the problems, for example, in Twisted in particular, is most Twisted APIs are not thread safe. So as long as you're deferring a function to a thread somewhere that does something on its own and does not bother Twisted, then this is, it's not the greatest solution, but, well, no, actually it is the greatest solution because you can ship software now. So yeah, defer to thread. Now, I've just talked to you about how you can put blocking code in Twisted, but maybe you want to put some Twisted in blocking code. Let's say you have an existing application, and there's something that you want to add to that application that Twisted would be just great for. For example, in my earlier example with the chat application that, let's just say it's a generic website, and you want to add some chat to that. You probably don't want to do chat over WSGI because, I mean, the request response model just doesn't really pan out. And you can add some Twisted to some existing blocking code using a fantastic piece of software written by Itamar, who is sitting in the front row. And it's called Crochet. What's Crochet? It gives you a function called setup. You call it one or more times, and it will go and run the Twisted reactor in a thread somewhere and do some extra magic like make logging work. But the most important thing, spawns a thread, runs a reactor in it. And then you get a decorator function called run-in-reactor, and you decorate any function you want. And what will that do? Whenever you call it, regardless of where you call it from, that function will be called in the reactor thread. And again, that's very important for when you're doing Twisted-y stuff, because most APIs in Twisted cannot be called from any other thread than the reactor thread. And then that thing will return an eventual result. What's an eventual result? Well, it's a synchronous counterpart of deferred. And you get this API. Apparently, the API is going to change soon, but not really significantly for purposes of this talk. You get sort of kind of a thing like a deferred, and you can tell it to wait with an optional timeout. And then whenever, if you don't pass a timeout right now, it blocks forever. So kind of like q.get, if you played with that. And you will eventually get the result out of that whenever the deferred that's backing, if you will, the eventual result fires. So as an example of this, this is a completely contrived example because, again, you would never actually use, you would just use Twisted directly here in this example. But you want to download a page with Trek, and that returns a deferred. So you do download page URL, you decorate it with a run-in-reactor. And this is, so now you're executing this in the main thread. That's not the reactor thread. The reactor is running somewhere else. And then you do a download page URL, and that's going to go, oh, OK, wait, this is a running reactor decorated function, so I'm going to go ahead and pass that off to the reactor thread. Reactor thread mulls it over, and then when you do result.wait, it waits until the reactor thread is done with this result. The deferred fires and gives you the result, and then you print it out. Now, again, there's no reason why you would do it this way, but this is, I hope you can see that this will easily map to more complicated examples. And as a more complicated example, let's try to demo. What could possibly go wrong? Yeah, of course, the interesting bits of the presentation are falling off. So what's going on here is there's Flask, or more accurately, WorkSoy. So that's the standard WSGI server that you get with Flask. It is serving the web page that you see down there. So with the current Euro to USD exchange rate. That's Flask just serving that. And in the background, there is Twisted that goes every 30 seconds, goes and fetches the new exchange rate and puts it somewhere where Flask can find it. So this is a good example of the big difference between this and the WSGI example earlier is that that was Twisted being the WSGI server. Here, you don't care what the WSGI server is. The WSGI server could be Unicorn, or in this case, WorkSoy. This is blocking code. This is completely blocking code, and it has no idea that Twisted is doing all sorts of neat asynchronous stuff in this other thread. So back to my slides. And just to look at some code, so here you have the Twisted part, you have class at the exchange rate, and you have, so the looping call, that just means like every 30 seconds, do this. And every 30 seconds, it does the download thing, which is then going to go get the current exchange rate and save it in the right place, yada, yada, yada. So the important part that I want to know here is that all of this Twisted code looks like Twisted code. There is nothing special or wonky going on here. The only thing that is not 100% Twisted is the run-in-reactor. And so, for example, the download method doesn't even need a running reactor because it's only going to get called by the looping call, which is going on in the reactor thread anyway. So it's really only like this simple little decorator that you apply to all of your entry points, if you will, where you're entering Twisted land, and then, yeah, then you get eventual results out of that. And well, in this case, you don't really particularly care about the eventual results because the method doesn't return anything interesting. But and then when you look at the Flask part, the Flask part is just getting EUR USD, that is in all uppercase. That is an instance, though. That's not a class. My brain couldn't decide if it preferred to stick to class naming style or the fact that instances should be probably lowercase. Anyway, it's getting the latest value from that object, and it's just serving that. So the Flask code, again, you're mixing Twisted and Flask quite intricately here. I mean, they're literally sharing the same objects. But the Flask code has absolutely no idea that Twisted exists. It just, there's some objects there, and I'm using them. So I think the very nice part here is really that the code, even though it's very, very intricately intertwined, they're at the same time completely oblivious of each other's existence. And programming is nothing if not something about local understanding. So, and as my final thing, pièce de résistance, if you will, twisted and G-event, because I figured if I can demonstrate that you can make twisted and G-event play together, then everyone's going to give up like, okay, fine, you can mix twisted with whatever you want. So there's a project, it's called G-Event Reactor. It is a fabulous, fabulous hack, and I still don't know if I mean that in the good or in the bad sense. But essentially what it does is it runs the reactor in a greenlit, and then for a number of things, including, for example, I think it's each protocol gets run in its own green thread. Basically, a lot of stuff gets run into its own, in its own green thread. You just have to call install once, because reactors are shared mutable state. Shared mutable state is awesome. And then you can write just blocking code in the middle of your twisted stuff. Like you have a twisted protocol, you have your def data received, and you can do G-event style blocking in there. You can, if you have again, when I say G-event style blocking, then I mean not real blocking. I mean the kind where G-event can make it look like you're not really blocking by, well, either munging the socket module or whatever. But you can do G-event coroutine suspending there, and the right thing will just automatically happen. And it also provides a bidirectional, in case let's say that you're marrying an existing G-event code base with an existing twisted code base, or one of the two is new, and you really want to, you have deferreds going from one side to the other, and you want to use them in the G-event code, or you have greenlets, and you want to use them in the twisted code, then there's a very neat bidirectional bridge. You can say wait for deferred, and you pass it to deferred, and that will actually pause the coroutine until the deferred fires. Whenever the deferred fires, you have your result, you unpause the coroutine, and you get the result in your coroutine. So again, that looks completely, there's no yield in there or anything, that looks blocking the way that you would want it to if you're writing G-event code. And that just works with the automatic suspension. And the other way around, if you have a greenlet, like, I don't know, like for example, you call, what is it, greenlet spawn, you give it a function, and it runs it in a coroutine. Let's say that, you have a coroutine, but what you really wanted was a deferred because you're about to pass it to, I don't know, gather results or some other neat deferred consuming API. Then there's a function, and you pass it the greenlet, and it will give you a deferred. So the nice thing about this is that even though you're marrying two things that really are miles apart in terms, yes, they use the same machinery very deeply internally, but I mean, G-event is still doing its stack slicing and whatnot. In the meantime, twisted is just being twisted. And they still manage to be entirely interoperable. And I guess I could show the example here, but so what I'm doing is I have a G-event coroutine, which gets the current CPU time. So CPU time is basically how much time the process is currently spent computing things, more or less. And twisted is serving that current CPU time. So again, this is a very simple example, but I hope you see that it at least demonstrates that pretty much any level of interop that you want to do between the two, I mean, you're sharing objects and everything, you can. So I guess I could show the demo. So on the right-hand side, which you unfortunately can't see entirely, no, it's not starting. Oh, that's unfortunate. So there's actually something happening on the left top half of the screen, which is currently not being presented. So as you can see, this is actually being updated more or less every second. Yeah, well, it was being updated every second. The clock, the CPU time, is much less than a second. So why is that? While G-event or twisted are sleeping, when they're not doing anything, they're waiting for something to happen, like, tell me when a set amount of time has happened. Then they don't really spend any CPU time. They just have some kind of lower level thing like select or epoll or whatever. And they tell it, like, OK, whenever this much time has happened, call me again. In the meantime, that process doesn't really have to do anything because it has nothing to do. So I think, let's go back to my slides. And so the code here, this is actually a single resource class. So for those who've never played with resources, this is a resource in the HTTP sense. So this is a web page, quote unquote, a single web page. That's a completely twisted thing. That's a twisted specific idiom. And at the bottom, you see the render.get. Can you guys see my mouse cursor? Yeah. At the bottom, you see the render.get, and that's how you respond to a GET request. And it's just returning the current CPU time. In the meantime, there is the def increment, which is just, this is a blocking loop. It does the gEvent sleepy thing, and whenever it's done, it will get the current CPU time and assign that to self.clock. So normally, in normal twisted, this would not really be possible because that while true loop would just block the reactor. And as soon as you call def increment, then yeah, it's over because the thing is just going to be sleeping forever and once in a while updating some state, but the reactor never really gets to do anything interesting. And what's happening in this case is the def increment is being run in a green thread, which means that it does the coroutine thing where it gets paused, and it just does, okay, I'm going to sleep for a second, update the clock, sleep for a second, update the clock. And this happens concurrently with twisted in the other green thread, but in the same thread. With twisted in the other green thread, still the reactor is still getting a chance to do I/O, still getting a chance to dispatch events and stuff like that. So in this case, in particular, serving HTTP requests. So the nice thing here is, again, that it's not like in order to marry a twisted in a gEvent code base, you don't have to do anything crazy. Like the gEvent code looks like completely, this could have been grabbed out of a piece of gEvent. There is nothing special about this code. And the render get is just, I mean, there's nothing special about it. This is like a very, very standard twisted resource. So it's not the case that you have to do really, really crazy things to get them to play together. So to recap, Twisted plays really well with others. There's a lot of supported protocols. Most of the things that you would want to do in a piece of software, there's a good chance that somebody's already tried to do it with Twisted. That doesn't mean that you can just go ahead and import it, but yeah, that's not Twisted specific. That's true for pretty much all software. It works with blocking code, and that's bidirectional. You can put blocking code into Twisted, you can put Twisted into blocking code, and they play together just fine. And it works with other event loops. I haven't really demoed that this much in this talk, but if, for example, if you have, I don't know, if you have a GUI app, most GUI apps will have an event loop of their own, and Twisted is very, very good at being able to interoperate with those. So if you have like a Qt app or a GTK app or a native OS X Core Foundation, was that Core Foundation? No, Core Foundation? Core Foundation, you can interop with that. So in conclusion, if you want to use Twisted, you probably can. That doesn't necessarily make it a good idea, although it obviously emphatically is. With that, I think, yeah, I could go to questions, and if there's not enough questions, then I can try to do a live demo, because I think we have about 5 minutes, right? No? Sorry? Okay, 1 or 2 questions, if there are any.
Hello.
Hi.
We have a twisted system that interoperates with AMQP, Thrift, XMPP, and some other protocols. It's great.
Yeah?
One problem we have is that with our code, we have all these different functions. Some of them are running in threads, some of them are running in the reactor. And for someone new to the project, it can be hard to tell which is which. Do you have any tips on code organization or other hints to future developers how to separate out code that's running in threads needs to be thread safe and stuff running in the reactor?
Right, so this is an extremely good question. It's in my opinion, is also the main weakness, that you still have to actively know which thread you want something to run in. And for example, you can't just go ahead and run a twisted API from a different thread. It will almost certainly just blow up horribly. And this is a very real problem. I think it really depends on the code that you're dealing with and your internal development processes. I don't really have a off-the-shelf solution where you can just go ahead and, where you can more clearly document, I guess, that something is going to go horribly wrong. So I don't know, and I think that's a very valid criticism.
Oh. Hey, kind of a related question. Say I have an entire Twisted app, and you recommended doing defer to thread for a blocking call, say talking to a database. Is there any way to make sure that that defer to thread, like that only spawns one thread ever? Like I don't want more than one
defer to thread generally doesn't cause threads to be spawned because defer to thread defer to thread works with the standard reactor thread pool. The reactor has a thread pool, and defer to thread by default uses the reactor thread pool. And if you use defer to thread pool, then you can give it an explicit thread pool in case that you don't want to compete with the reactor thread pool. So generally, defer to thread, even though it's going to run something in a thread, it's using a thread pool, so the threads already exist. Does that answer your question?
Uh-huh.
Okay. And my chair said that I can't take any more questions. So sorry, but I will happily take your question once we're off the stage. All right. Thank you.